I feel it's a deep privilege to stand before you on this august gathering of inviting the eminent resource persons, respected dignitaries, faculty members of various departments in and around the state of Andhra Pradesh, delegates, coordinators of various wings, heads of the departments, all the faculty members, teaching and non-teaching staff members, members of print and electronic media, and all media student friends. It's a great honor and pride to introduce myself. I am Dr. J. Suresh, representing from the Department of Chemistry. Government Autonomous College is one of the premier institute in the state of Andhra Pradesh. It is one of the oldest and the largest institution, established in 1853, with a vast potentiality of learning resource center. The college is, this institution is having 52 programs and 14 PG programs. And the Department of Chemistry is one of the biggest and the largest department in the state of Andhra Pradesh, where all the regular teaching, contract and guest faculty are more than 30 members. So at the outset, really it's a great and pride that the Department of Chemistry came with a innovation idea to try to conduct this program in the name of Reach 2022. Dear students, today the whole world has reached to 8 billion of population. The total population of the world is 800 crores as per the reports embedded by the United Nations Development Program. Our country has reached to 146 crores of population. Now it's the time for us to try to safeguard this human existence throughout the world and throughout the society. Based on the criteria of the consideration, the Department of Chemistry has came forward with an innovative project to try to conduct a program on the recent evolutionary and applications of chemistry 2022. So at the outset, we convey our sincere thanks to our Joint Director of Higher Education and our beloved principal, Dr. Rapaka David Kumar Sir Garu, the principal of this prestigious institution. Now I invite one more an eminent distinguished members of our institution, Sri Saila Shastri Garu, the in charge of the department, in charge of our institution and head of the Department of English, to come on to the stage and occupy his seat. Thank you, sir. I feel it's a proud and honor to invite my teacher, my mentor, the Regional Joint Director of Higher Education of Rajahmundry Zone, who is working as a principal and special officers for various wings, a good and able administrator, a wonderful researcher, what not everything. Our beloved and respected Dr. C.H. Krishna Garu, the Joint Director for Zone 1 and Zone 2 of the Regional Director of Higher Education, please come on to the stage and occupy his seat, sir. It's a great honor and pride from the Department of Chemistry. So we have invited the ONGC Executive Director for Rajahmundry Assets, Sri Amit Narayan Garu, but because of his hectic schedule, he will join in the later course. He will be the chief guest for today's national seminar. Now I invite one more recipient, a great academician, a good researcher in the areas of chemical sciences, the head of the Department of Andhra University, Voltaire, from the School of Chemistry, our beloved Professor Dr. P. Shamala Madam Garu, to come on to the stage and occupy his seat. Please, madam. Thanks, madam. We were the batchmate of the orientation course at Andhra University in 2007. Along with Siddhaya is my classmate. It's a long way to see you, madam. Now I invite Dr. Rambabu Dandella from the Institute of Chemical Technology, IOC, long way from Bhubaneswar. So as one of the resource person for today's session, now I invite Dr. Rambabu sir to come onto the stage and occupy his seat. I invite one more resource person and dignitary as one of the guest of honor for today's session, Dr. Tirupati, Assistant Professor from Indian Institute of Science and Education Research from Bhubaneswar. Sir, please come onto the stage and occupy his seat. The Government College Autonomous are the two eyes of our institution. One is IQAC and one is academic cell. So without IQAC and academic cell, the entire administrative and academic activities will not take place. So reaching to a high echelons of NAC A plus grading, it's not an easy task. It lies in the two hands of our two eyes of this institution. Now I invite our beloved IQAC coordinator, Dr. A. Annapurna Madam Garu to come out to the stage and occupy his seat. Please, Madam. I request the student to present a bouquet to our IQAC coordinator, Madam. I invite one more, the pillar of this institution of our college, GCRJY, our respected academic cell coordinator, Dr. Manova Raghava Gautam Garu, the academic cell coordinator of institution, to come out to the stage and occupy his seat. I feel proud to say that this entire programs, right from the micro level to the macro level, is being embedded with one lady of our institution, our beloved head of the department, Dr. Sunita Madam. But because of his certain emergency work, she could not be able to attend for today's program. Now I invite the head of the department in charge, J. Yacob Garu, to come onto the stage and occupy his seat. Now I invite the convener of this program, the recent evolutions and applications in come on.
It's now time for the prayers. I request the prayer team.
या कुन्देन्दु तुषारहार धवला या शुभ्रवस्त्रान्विता या वीणा वरदण्डमण्डितकरा या श्वेत पद्मासना या ब्रह्माच्युत शङ्करा प्रभृतिभिः देवैः सदा पूजिता सा मां पातु सरस्वती भगवती निःश्लेषजाड्यापः. Thank you everyone.
Sir.
Dignitaries on the stage. Excuse me. Hello. honored dignitaries on the stage, my colleagues, the organizers, and my dear students. I'm very sure today is going to be a milestone in the annals of the Department of Chemistry, because we see almost the entire Department of Chemistry, the luminaries in chemistry, seated on the stage. As a man of literature, I know only the meaning of chemistry as a process that turns out a magic, like the chemistry between the people. By the end of this 2-day program, I'm very sure and I strongly believe that these dignitaries on the stage will definitely prove the chemistry that their lectures will turn out among the students. Chemistry is called the queen generally of all the sciences, in the sense it has become an indispensable interdisciplinary program. Be it botany, be it zoology, or be it biotechnology, whatever you call, without chemistry, they are treated handicapped. A lot of modern research is now going on. Just the other day, we were afraid of chemical weapons being used on Ukraine. So in the area of defense, in our day-to-day life, the application of chemistry is acquiring great and unimagined proportions of importance. So I'm very sure the 2-day program and the great lectures that you are going to listen to are not only going to motivate academicians, research scholars, and our faculty members and others. I have a small request to the academicians on the stage. Please try to bear our undergraduate students also in mind and try to motivate them in the way that every student turns out to be a great researcher. Every student feels proud of studying the subject, and every student should be motivated enough to contribute something valid to the subject. After all, it is the passion that makes people do anything. And I'm very sure the 2-day activities that we will hold here will definitely create that kind of passion among the students and make them go ahead in leaps and bounds. Thank you very much. Now it is the convener's concept. I request the conveners. Please come. So you have a mic, I think.
Thank you, sir. Respected dignitaries, our beloved RJD sir, Dr. C. Krishna Garu, in-charge principal of the college, Sri P. C. Sailasastri Garu, Professor P. Shyamala Garu, HOD Department of Chemistry, Andhra University, Dr. Rambabu Dandela, Institute of Chemical Technology, IOC Bhubaneswar, Dr. Tirupati Garu, Assistant Professor, ISER, Berhampur, Odisha, Sri J. Yakob Garu, today's in-charge HOD of Chemistry Department, Dr. A. Annapurna Garu, IQAC Coordinator, Dr. M.R. Gautam Garu, Academic Cell Coordinator, Sri T. Srinivasarao Garu, Lecturer in Chemistry and Organizing Secretary of this program, my dear colleagues, research scholars, and above all, my dear students, good morning to all of you. You all are most welcome to the 2 days National Conference on Recent Evolutions and Applications in Chemistry, that is REACH 2022. I am acting as convener for today's program. I am B. Venkatrao, lecturer in chemistry on behalf of Dr. Sunita Garu. She went to attend some unforeseen occasion. On her behalf, it is my privilege to express my greetings on the occasion of today's National Conference on Recent Evolution and Applications in Chemistry on 18th and 19th November 2022. Chemistry is such a diversified subject without which the present living standards of the society must have not grown. The subject has its importance in all aspects of the society, on the health of the human life, social life, and also on the environment. There is no subject without the traces of chemistry, and appreciate all the working chemists and chemistry teachers for their sincere efforts to bring health, happiness, and for better environment through their relentless R&D activities. I wish successful and meaningful culmination of this conference. Thank you, President Sir, for giving me this opportunity. Thank you, one and all.
I now authorize Dr. Suresh to take over the program and invite people according to the schedule.
So thank you, sir. Now I invite today's head of the department in charge, Sri J. Jacob sir, to try to address the gathering.
Good morning to the today's conference chief guests and dignitaries on the dais, especially our beloved David Kumar sir, joint director and principal, and in charge principal Sastri sir, and remaining resource persons, and my dear colleagues and my dear students, good morning to all. A few words about our department of the chemistry. The department of chemistry of this college is one of the oldest department in the state as well as the country. The department started UG courses in 1891 and PG courses 1971. At present, the department of offers 17 UG courses, 3 PG courses and 2 certificate courses. And the department has a research center organized by the Andhra University, Visakhapatnam in 2005, and also by Adikavinarna University, Rajahmundry in 2017. The Department of Chemistry has 28 regular faculty, among which 14 doctorates and 3 research guides, and 3 research scholars are pursuing their doctoral studies. Many of alumni of this department are well placed in various national and international organizations, and the department involves outreach, social activities like lab to school, lab to land. It has best practices like micro scale experiments in lab, plastic free day, ozone day, rack chemicals, and joy of giving, etc. And also I welcome to two-day national conference in recent evaluations and applications in chemistry, and the chief guests and guest of honors and resource persons all are welcome, sir. Thank you. Thank you so much.
Thank you, sir. So now I invite our beloved Regional Joint Director of Higher Education, Dr. C.H. Krishna Garu. So he is a well-known personality throughout the state of Andhra Pradesh, especially in the areas of research, academic and administrative are concerned. So he worked in various disciplines, in various walks of administrations, as a special officer, as a lecturer, then as a professor, as a principals of various colleges, and presently he is working as a regional joint director. So no need to have a much more introduction because he is a well-known personality in the state of Andhra Pradesh. Now I request our beloved RJD sir to try to address the gathering. Please, sir.
Good morning to everybody. Welcome to two-day National Conference on Recent Evolutions and Applications in Chemistry. Today chief guest Professor P. Shyamala Madam at the Department of Chemistry, Andhra University, Visakhapatnam. Resource persons Dr. Rambabu Dandela, Institute of Chemical Technology, IOC, Bangalore. Another resource person Dr. Tirupati, Assistant Professor, ISER, Barampur. Dr. Bibhat Bhushan Parida, Assistant Professor, Barampur University, and in charge principal of this college, Sri Sisela Shastri Garu. Chemistry, today's department in charge, Jacob Garu. Convener Venkatrao Garu, Arranging Secretary T. Srinivasarao Garu, and IKC Coordinator Dr. A. Annapurna Garu, Economic Coordinator Dr. M. R. Gautam, respected dignitaries on the dais, of the dais, faculty, researchers from department, different parts of the nation, research scholars, print and electronic media, my dear students. Very good morning and warm greetings to all. It gives me immense pleasure to stand before to address you on this occasion. At the outset, let me congratulate the organizers of this today's National Conference on Recent Evolutions and Applications in Chemistry, REACH 2022. Many youngsters in the current generation believe that India did not know anything about science in the past. Further, they may also think our ancient sculptures were purely religious and did not include any scientific knowledge. Some of the young people also think that it was the Britishers who taught us science and that prior to them, India was ignorant of modern science. This is not true. I made some study out of curiosity on this topic and try to understand some antique manuscripts and books on our early history that had been written by indigenous people. While doing that, I came across many texts about ancient Indian science, including astronomy, chemistry, mathematics, earth science, etc. Finding these materials made me realize how less we know about our ancient past and India's intellectual caliber. Now I would like to mention the practice of chemistry in ancient India. India has a very ancient tradition of chemistry. In ancient texts, imaging information is available on metals, ores, their qualities, compounds and alloys. There are also details of hundreds of devices used in chemical experiments in Rasayana Shastra, which we call chemistry. There have been many chemists in the past in India, to mention a few and their creations. Acharya Nagarjuna, Rasratnakar, Vagbhat, Rasrasna Samuchay, Govindacharya, Rasanava, Yasodhar, Rasaprakash Sudhakar, etc. In the book Rasratna Samuchay, the following substances were listed as the principal substances: Maharsh, Uparasha, Samasha, Ratna, Dhatu, Vishu, Kshar, Amla, Lavana, Lohabhushan, etc. The book also discusses 10 different poisons that could be utilized for medical treatment in a similar manner. The 7th chapter of the Rasaratna Samuchai includes a description of chemistry lab. There were more than 32 instruments used and described here. Acharya Nagarjuna has conducted a number of studies involving mercury in lab. He went into great depth on how to clean mercury and use it as medicine. In his writings, Nagarjuna outlines the process for mixing different metals, purifying mercury and other metals, cleaning mahars and tuning other metals into gold or silver. Mercury was employed for longevity and good health as well as for the conversion of metals. Beginning in the early 18th century BC, mankind began learning about new elements. Prior to this, 7 metals were known to mankind. They are gold, silver, copper, iron, tin, lead and mercury. All of these metals are specifically mentioned in our ancient texts such as Rigveda, Yajurveda, Atharvana Veda. The Vedas date from roughly 1000 BC. The evidence leads us to believe that the science of chemistry originated in India at approximately 1000 BC. Similar references to the well-known Sushrita Samhita and medical experiments with mercury, zinc, copper and other metals and obtaining their pure from their alloys may be found in fast Vedic era. It goes without saying that such expertise, knowledge in the field would have been obtained far earlier. It is significant that Kautilya, who wrote the Ardhashastra in the same century as these texts, 3rd century BC, made references to metals, alloys, minerals and ores. Many other items, iron, soap, ammunition, indigo, ink, sulfur, copper, zinc, etc. are also being prepared from Indian technology at that time and later as well as. Very soon after the advancement of Western technology during the British rule, Indian technology was forgotten. These are only few examples that demonstrate that India has had a magnificent tradition of chemical research for thousands of years. Therefore, I request the youngsters sitting here to adopt the state-of-the-art technology to grow personally. At the same time, refer to Indian ancient texts for excellent guidance and holistic development. I wholeheartedly wish that Reach 2022 would definitely reach the expectations of the innovative India. With this, I conclude my speech and once again congratulate the organizers for organizing this national conference, and I wish the deliberations of this seminar would definitely contribute the national building. Thanking you. Jai Hind.
Thank you, sir, for your valuable words. That inspires a lot for the younger generations. So India is a very vast potentiality. From the Vedic period to till today, there is a lot of progressive development of science and technology that is taking place on this earth. There are so many unsolved problems, unanswerable questions have been remained in this huge population. So definitely these deliberations and conferences proceedings may bring a great success for the betterment of society. Thank you very much, sir. Now I invite our GCRJY IQAC coordinator, Dr. A.A. Annapurna Madam Garu, to address the gathering. Please, madam.
Thank you, sir. At the outset, I would like to extend my all respects to the chief guest, Shri Amit Narayan Garu, our guest of honor, Dr. C. Krishna Garu, Regional Joint Director for Zone 1 and 2, Collegiate Education, AP Rajahmundry, And also I would like to extend my same respects to P. Shyamala garu, T. Pavan Kumar garu, Ram Babu garu, Tirupati Barla garu, and Bhushan Farida and Fani Kiran garu on the dais, all the dignitaries on the dais. And also I would like to extend my heartfelt congratulations to the Department of Chemistry for organizing such a educative program on recent educations and applications in chemistry. As my predecessor speakers have expressed, chemistry is found all over. So, I wish all the students and the participants of this program gain the maximum from the deliberations for these 2 days on this platform, and I wish all success for the organizers of this program. Thank you for giving me this opportunity.
Thank you, madam, for your warm greetings. Now I invite the keynote speaker for today's morning session, our beloved and respected Dr. P. Shyamala Madam Garu, Head of the Department of... Now I invite from the Department of Chemistry, our colleague Padmaja Madam Garu to give a brief profile about Dr. P. Shyamala Madam's. Please, madam. Yes. Madam, 1 minute, madam, before the biodata.
Good morning to one and all. I am Padmaja, lecturer in chemistry. Today, I am fortunate to introduce today's keynote speaker, Dr. P. Shyamala Garu, Associate Professor, Head of the Department of Chemistry, Andhra University. Madam obtained her undergraduation from Andhra University, MSc, MPhil from University of Hyderabad, PhD from Andhra University. She joined as Assistant Professor in Andhra University in the year 2006. Currently, she is working as Associate Professor, Head of the Department of Chemistry, Andhra University. Her research expertise are kinetics, reverse micelles, seawater quality monitoring, cloud point extraction, micelles flocculation, etc. Madam has wide teaching experience of 16 years and research experience of 24 years. Madam has published 94 papers in various national and international journals. She has presented 12 papers in national and international conferences and has 2 book chapters to her publication credit. She has guided 30 PhD scholars and 2 MPhil scholars. Madam received many grants from central funding agencies. Mention few are DRDO, CARS, DST, SERB, UGC. Madam has 1 patent to her credit. She organized various FDPs, conferences, seminars, workshops. She holds membership from various professional bodies. She received Best Researcher Award, School of Chemistry, Andhra University in 2001 and Ugadi Puraskaram in 2020 for outstanding accomplishments and contributions in the field of teaching, research and administration. It's really great honor to have you with us today, madam. Let us clap and invite Dr. P. Sailaja Madam Garu. Thank you.
Please, madam.
I thought the keynote address is going to start now. Anyway, respected guest of honor, Dr. C. Krishna Garu, the chief guest of today's function, Sri Amit Narayan Garu from ONGC, then the convener, the organizing secretary, and other dignitaries on the stage. A very good morning to all of you. I'm so happy to be here today because it is like nostalgia for me coming to Arts College, Rajahmundry. Until very few years back, this was under Andhra University and I was a regular examiner for MSc Chemistry last year. So past 7 years I didn't come, sir. after it has gone to Nannaya University. And so many of my students, my teachers, my colleagues are from this place. And I really feel good to be here today. Having said this, I would also like to thank the principal of the college, who is he, sir? Dr. David Kumar, sir, and the convener, Dr. Sunita, for inviting me to be here as a keynote address today. Sunita is my PhD student, actually a very hardworking and sincere student who is capable of organizing her own work and writing her own papers. I wish her all good luck, though she is not here. I would like to congratulate her for organizing this event and bringing me here today. And coming to this kind of seminars, this is especially for the students, we normally teaching is of many kinds. So even in the classroom you get to listen to lectures and all, but this is a different kind of teaching where you get to interact with people. There are so many resource persons coming from various national institutes, and this is a different kind of learning for you, where you will learn new skills, you can chance to discuss with them, you can clear your doubts and listen to new topics and the latest topics, that is recent evolutions in chemistry, as the title goes. So I request all of you to concentrate, interact with the resource person and learn something. It's just not you're that made to sit here and from your class you're coming here and spending some time in this hall. Okay, you should learn definitely something at the end of these 2 days. And there are some very good people coming who have lot of knowledge in chemistry, coming here to talk to you. Okay, so I will also be talking to you very soon, and I want you to be very interactive with the resource person. Otherwise there is no point in us coming all the way from Visakhapatnam, Orissa and other places. We have come here only to talk to you and to tell you something, our thoughts, sharing with you, and we will go back. Okay, and coming to the title, okay, recent evolutions in chemistry, maybe we should say there are so many revolutions in chemistry. We have been seeing from the alchemist time, you know, the ancient chemistry is called what? Alchemistry. Alchemists. Chemists were called alchemists at that time, and this subject called chemistry was developed somewhere around 1700s. At that time, chemistry was started developing, and the purpose of an alchemist was only to do some transformations, like Krishna sir was telling. Their interest was only to transform some matter into another matter. Like suppose everybody is interested in gold, yes? So they always wanted to turn lead into gold, and they wanted to remain young and healthy. So they were trying to find out some solutions for these problems. And I remember some king of Poland once, he jailed one alchemist, okay, and he asked him to convert lead into gold. Okay, he couldn't do that. His only job was he was given lead, I'm talking about 1700. His job was to convert lead into gold. Poor thing, he could not do that, but he made porcelain. Porcelain, the king was happy because porcelain was also very useful those days. Until that time in Poland they were importing from China. So they had a choice, they have a solution. At least Europeans are very interested in porcelain and decorative things. So he was happy and he left the alchemist. So people are continuously trying to, chemists especially, they are trying to transform one material into another. Since that time this subject started, and philosopher's stone, it is called, an imaginative stone, which also comes in your Harry Potter. Okay, it is an imaginary stone which they believe is going to do all these transformations or conversions. So this was the idea with which chemistry started, and since then it is going on evolving till today, where we are talking about click chemistry and bioorthogonal chemistry. You must have heard of these two terms. Have you heard of this term called click chemistry and bioorthogonal chemistry? Yes or no? I am talking to the students. Have you heard, where did you hear of this term called click chemistry recently? Yeah, the Nobel Prize? 2022, yes. It was for click chemistry, and who were the scientists? One of them was Sharpless. You would have heard of Sharpless epoxidation in your classes. He is the same Sharpless. Okay, so from there it has come to click chemistry and bioorthogonal chemistry, which is going to solve problems and a treatment for anti-cancer. They are anticipating will come out from this subject called click chemistry. So this is how chemistry has been evolving, and during this time there are so many revolutions that have taken place. Okay, maybe with this few words, I will stop now. I'll continue a little while later on disruptive technologies in chemistry. I thank once again the organizers for giving me a chance to speak. Yeah.
Thank you, madam, for your wonderful speech. Now, as a token of our gratitude, so it's a great honor from the Department of Chemistry to host this great event. Now, we cordially invite our beloved and respected Regional Joint Director of Higher Education, our beloved RJD Sir, Chapri Krishna Sir, to take part in the field station. Please, sir, on behalf of the entire organizing committee. Field station, please. So I request all the organizing committee, the faculty members. Okay, front, okay, chair front end.
ఈ చైర్ ఆగే
ముందు పెట్టేస్తారా ఇది ఇప్పుడు అయిపోలేదు ఇంకా టీ బ్రేక్ చెప్పనా
Let me see if I can complete in 20 or 25 minutes, okay? So the topic is disruptive technologies in chemistry and in particular lithium-ion batteries. So
ప్రాజెక్ట్
okay. So, because I use the term called disruptive technologies, I will tell you the difference, what is meant by a disruptive technology. And if I should tell you what is meant by disruptive technology, I should tell you what is a sustaining technology. So, see, just like if we buy a fridge or TV in the house, okay? So, normally what do we see? We see the price and the other is the features, we say, which TV is better. Okay, so TVs also, since the past, like for example, the fridges, refrigerators that we are using. So we started with what? Initially there is only single door fridge. Then later on, some double door. Then a little later, we have so many other facilities in the same fridge. Fridge is there, but some small changes are made onto the fridge. So that is what, so which one are we buying? The one that is having more features and the one that is costing us less money. Okay, this sustaining technology is something like that which has a subtle and gradual impact on the society. Okay, so that means the fridge is not getting eliminated in the society. Fridge is there, but the improvements are made on the fridge. This is called a sustaining technology. And the green chemistry that all of us know in chemistry comes under this sustaining technology. Then what is a disruptive technology? Disruptive technologies are called breakthrough technologies, which until that time you won't have heard of them. So suppose it's a fridge, refrigerator, you know there is an old type of a refrigerator, there is a new type of refrigerator. But I am talking about something, till that time you wouldn't have heard of it. Suddenly it comes to the market and all the other existing ones are gone. And from that time, we only talk about this particular item or something. To give you an example, I will tell you about, like for example, earlier for watching a movie, we used to see a cable TV, if you all remember. Yes?
cable TV, we pay money sir for a cable TV, and they put some movie for us. So nowadays what are we doing? So nobody even remembers of cable TV. I don't know if you people know that also. Isn't it? Now we are only talking about Netflix. What else? You know that better. What? Prime Video, Hotstar, all this. So when we were young, we only know of cable TV and all. So suddenly that is vanished and something new has come. And another example that I can give you, belonging to this category, is there I have written something, and taxis. When we had to go somewhere earlier, when we were young, we used to go to an auto stand or a taxi stand and bargain with that guy and get into the taxi. But nowadays what are you doing? You just use your phone and all your Ola, Uber, and I don't know how popular they are in Rajahmundry, but Visakhapatnam and other places, we only use our phone nowadays to call a taxi. Yes? So this is another disruptive technology. So what is the main characteristic of a disruptive technology? It should have definitely technology wise it should be good. At the same time it should be cheap. Otherwise it will not go to everybody. People will not be interested in that if it's very costly or expensive. So if you see what is a disruptive technology, see the second part, the technology should have other properties like it should be less expensive, it should be more robust, smaller, lighter, and it should require less energy, and it should be more flexible. This kind of a product or technology that comes having these features will wipe out the existing ones. This kind of a technology is called a disruptive technology. Okay, now I told you what is meant by a disruptive technology. So you understood the difference between sustaining and disruptive? Yes, sustaining means it is already there, we are making small improvements to it. Disruptive, until that time you don't know what it is, suddenly it comes to the market, it comes so much that it wipes out the existing ones. So we also call it a breakthrough technology. So I am going to talk to you about such a breakthrough technology now. What is that? So this starts with our oil crisis. This is a graph which shows, see the upper one and the lower one. The slope is less for the upper one, but here the down the slope is more. Means in a very short time this technology picks up, it goes into the market in such a way that the existing ones are not anywhere until after that time they no longer exist. And then, so one such disruptive technology I am going to talk about, where the starting point is the oil crisis. We already know in 1973 there was an oil crisis, 1979 another oil crisis, and 1990 another oil crisis. Means, oil means what? Petrol. So petrol is getting exhausted, so we are trying for alternate energy resources. In that, so there was these alternate fuels, they were trying for hydrogen, biomass, herbal fuel and gas hydrate, but all these failed. For an economist, this is a big subject called disruptive technology. Whether a particular emerging technology, is disruptive or not. It depends on so many things. I should say it should be cheaper also, it should be available to everybody also. And they tried these alternate fuels, but they were all failed to enter into the market. So they were still searching for something, and the solution we have is called, now this is a big disruption, means a big breakthrough has come in energy sources, that is the electrochemical devices, electrochemical storage devices. See the car there that I showed you, that's not a petrol station, that is a EV vehicle, which we are called electric vehicles now. That's a charging point for that particular car. And the company that you can see is Tesla, which was the first company which introduced the EV vehicles or electric vehicles. Some more devices which run on these electrochemical storage devices. There I showed you the lithium battery, your laptops, your mobile phones, your lighting equipment, more so your electric vehicles and bikes also nowadays. Some of you must be having bikes which are run on EV. Yes? How many in this hall? At least I think the latest bikes that are coming are EV bikes. And the cars, of course, the military equipment, if you go to NSTL in Visakhapatnam DRDO, they are all using this battery for naval applications. Okay, so this is a major breakthrough for energy requirement. Okay, and these electrochemical storage devices are of 3-4 types majorly. One is capacitors and supercapacitors. The principle is the same, except that supercapacitor is bigger than a capacitor, and then you have batteries and a fuel cell. These are the different types of electrochemical storage devices. And the advantage with these electrochemical storage devices is they are environment friendly, and their absence of gaseous exhaust are there, easy to scale up, and conversion efficiency is high. And to tell you about, I want to focus on lithium ion batteries. So before I tell you about lithium ion batteries, I should tell you the difference between capacitor and a battery. You can see two pictures there. One is a capacitor, which is green in color, and other is the red one, which is the battery. From the battery, you see the energy that is flowing out. The battery is big, the size is big, but the amount of flow you can see is small. But in a capacitor, you see, though the capacitor is small, the amount of whatever the energy that is coming out is more. So this is the difference between a capacitor and a battery. So did you understand the difference between a capacitor and a battery? So one is energy rich, and it's supposed to be energy density is high for a battery, while power density is high for a capacitor. It's also compared to a marathon runner relay race and a 100-meter race person. What does the marathon race person do, or the relay race? He saves his energy for all the 4 relays. Okay? While the 100-meter person who is running, he has to give off his energy very quickly. Okay? So the one that gives off energy very quickly is a capacitor. The one that has lot of energy but gives out energy slowly is a battery. Okay, so this is the difference between a battery and a capacitor. Both capacitors and batteries are very good electrochemical storage devices, but depending on the purpose or the need, we should use them. Okay, so how many types of electrochemical storage devices? 2. One is battery and the other is capacitor. What is the difference between them? Battery is energy rich, capacitor is power rich. So this is another, you see this graph where I have an energy capacity on the x-axis and a discharge time on the y-axis. So you can see the capacitor, the violet one, is towards this side, whereas the batteries are coming to a little on the right hand side, meaning that the discharge time is less for a capacitor compared to a battery. And this is again energy density versus power density. Where are the conventional batteries that I am showing you is the yellow one, and where are the capacitors? The blue one is the capacitor. Did you see that? So what the x-axis is power density. So if you can see, power density is more for capacitors, while energy density is more for a conventional battery. Okay, and before we go into the lithium ion batteries, I hope you know the difference between a primary cell and a secondary cell, because I am talking to undergraduate students also. I thought you should know the difference between a primary cell and a secondary cell, and what is the difference between a cell and a battery. Can you tell me? What is the difference between a primary cell and a secondary cell? Both are galvanic cells. Okay? Chemical energy is converted to electrical energy, but if you use it, you will have to throw it in the case of primary. In the case of secondary, it is rechargeable. Yes? Okay. Now what is the difference between a cell and a battery? A group of cells is called a battery. Okay? And I will show you the biggest revolution in chemistry that I was telling about is the lithium ion batteries, for which the 2019 Nobel Prize was awarded. And 3 scientists, 2 from USA and 1 from Japan. The one is good enough, other person was Whittingham, and Akira Yoshino. These 3 got the Nobel Prize in 2019 for the development of lithium ion batteries. So let us see what is the first, and coming to again, what is it we look in a battery nowadays? Earlier also we had some batteries, no? Before lithium also we had some batteries. What are those batteries that you know? The pentode cells that we are using. Inka? What else do you know? the one that you see in buses and cars, they are called lead acid batteries. You must have studied this in your intermediate about lead acid batteries. Okay, so what do we look for? Why are we not satisfied with a lead acid battery or a small galvanic cell? See, two things we look about is the size and the energy. So I told you about two things. One is the size and the other is the weight. If you see here, you see the blue one, the first one is lead acid, and the last one, orangish red one, is a lithium ion. What is the characteristic of lithium ion there? It is having both small size and it is lightweight also. Size also should be small, weight also should be less, and it should give maximum efficiency. These are the requirements for a battery that we are looking into. Because suppose you should take a battery into the space, for spacecraft, it should not be big, it should not be heavy. So we are looking for such kind of a battery where the specific energy density is also more and the volume energy density per liter is also more. Means it should have a small size and it should also be less in weight. So Whittingham started this battery by using titanium sulfide as this is the battery that was discovered by Whittingham, where he used titanium disulfide as the cathode and metallic lithium as the anode. So what happens during oxidation? I am talking more about electrochemistry only today. Okay, what happens in oxidation? Or what happens at the anode? At the anode, oxidation takes place. Oxidation means what? Electrons are released there. So, and the anode is lithium. Okay, when lithium gives off electrons, lithium ions are released. These lithium ions go and intercalate into titanium sulfide. That means they go and just sit in the layers between the titanium sulfide. This was the lithium ion that was invented by Whittingham. And you can see the power that I wrote there, the potential, that is 2 volts. Using this battery, you can get a power of 2 volts. So this was the battery created by Whittingham. So then, what good enough did? So I said titanium sulfide is known to be a good intercalation compound. You must have learned about intercalation in inorganic chemistry, where these ions, the lithium ions, go and sit in the titanium sulfide layers. But Goodenough said he took metal oxide instead of sulfides, because he assumed metal oxide would have given more power compared to metal sulfide. And this time he took cobalt oxide. He took cobalt oxide as the cathode and again lithium as the anode. And using this setup, he could get, instead of 2 volts, he could get 4 volts. The normal batteries that we were using until lithium were all only 2 volts. But Goodenough made a battery with 4 volts. That means what? It is twice as powerful as the one that was created by Whittingham. Okay, this was another breakthrough by Goodenough. So I have told you about 2 kinds of batteries now. One with titanium sulfide as the cathode and the other with cobalt oxide as the cathode. The anode was always lithium metal. Till now, the anode that was used is lithium metal. And the problem was with these 2 types of batteries was, you can see there's something called viscous there. Something called viscous there. So during oxidation, lithium ions go to the cathode and the reverse process takes place in the reduction. So when this kind of lithium ions going front and lithium atoms coming back, when this is happening, some viscous are produced, and when the 2 electrodes may touch each other, when the 2 electrodes touch each other, the fire is produced. It gets short circuited and fire is produced. Okay, so the point is now, so where are we? So we should have, okay, we have got 4 volts, but now we should reduce this kind of a phenomena. So what they did was, Akira Yoshino, he took, now, instead of lithium, I'll show you the picture there, he took petroleum coke as the anode side, so that lithium ions are also intercalated in the petroleum coke. And any battery, 2 kinds of process should take place, charging and discharging. This is a phenomenon that we are seeing even in our mobile phones. Every day you put your phone for charge, no? Today we will, after this talk, you will know whether you can use somebody else's charger or not. Is it good if you can use somebody else's charger and put the charge for a long time or not? We will see at the end of this talk. Okay? So first what we should do now, we should avoid the lithium fire that is called. So they were trying for it, and I already told you about Akira Yoshino is a Japanese who invented, he said petroleum coke should be used along with lithium at the anode. And then this problem of short circuiting will be or can be avoided. So, and I am showing here the two processes that take place in any battery. One is charging and the other is discharging. Discharging means what? Whatever is there in the battery is used to light up a lamp. That is called a load there. Okay, so you see the anode is anode. The electrons are coming from the anode to the cathode. Oxidation takes place there. What happens? Lithium ions are produced. Those lithium ions go to the cathode. Whereas in charging, the reverse process happens. See, the electrons are going to the anode. Electrons are going to the anode, and lithium ions are coming in the opposite direction. I have another animation here. No, one second. This is an animation. In this picture, you see the battery there. The big one. There should be a start button. You see the picture right now. No, this one. You see? I'll show you again. You see the charge meter there? Now it is empty and the car is on the other side, turning the other side. Means what? It is getting charged now. Like your phone, it is getting charged. The electrons are going to the anode. The electrons are going to the anode. Now see the discharge. Discharge, electrons come out from the anode. It is gone now. So the discharge meter, when you see the charge meter, it is full. It is full. See, now it is getting empty. That means you are using that charge to drive a car. You are using it to drive a car. Now it is totally, battery is not there. Now it has to get charged using a charging station. Okay, this is what happens in a lithium-ion battery. And these are, because we are chemists, we should know the equations that are taking place at the anode and then at the cathode. You can see, we start with the, whenever we are talking about electrochemistry, we first talk about oxidation process, which releases electrons. See the second step, carbon is from the cathode. It has, the lithium is there. Is it that? Yeah. So you see the last reaction there, lithium cobalt oxide plus 6 carbons gives some of the lithium ions go into the graphite that is there. And these are the basic materials in any lithium ion batteries. I just showed you the inside of how a battery looks. And the advantages, and commonly whenever we have a cell or a battery, along with the anode and the cathode, you also need an electrolyte. So the electrolytes that are commonly used are lithium salts in an organic solvent, ethylene carbonate, dimethyl carbonate and diethyl carbonate, and also nowadays solid electrolytes are also used, some solid ceramic electrolytes are also used. Coming to the advantages. Now you can tell me the first advantage that is in lithium battery is what? It is producing 4 volts instead of 2 volts. That is the first advantage. And then they are light in weight. Lithium is one of the lightest metal you know, so they are also light in weight. Why lithium? Because it is the lightest element that is known. Okay, and they are light in weight. They don't require a lot of maintenance, and they don't have memory effect. Memory effect means, earlier if you remember, when you were charging a phone, at least people at my house, they used to tell you leave it until it is completely charged, only then take it out. And don't charge it again until it is completely decharged, until you see 0. That is because the earlier cells had a memory effect. Now that requirement is not there. This kind of a memory effect is not there for lithium batteries. But they have a capacity, they have a self-discharge. If you just leave it like that, they lose, they get, the reactions take place, and over 2 to 3 years, it goes up, the chemical is transformed. So the lifetime is there, that is 2 to 3 years, whether you use it or not. Whether you use it or not. Earlier ones are all your nickel cadmium batteries or lead acid batteries, which were all, lead is toxic, cadmium is toxic. Whereas that is not there in the case of lithium. And of course, we are talking about clean and green all the time. It is in the green perspective also, lithium ion has lot of advantage. Now, I put a lithium ion battery stores 150 watt hours of electricity for 1 gram of the 1 kilogram of the battery, while a nickel metal hydride or a lead acid battery, see, one is only giving you 100 watt hours, and the lead acid battery that we know in cars and buses that is used is only giving you 25 watt hours per kilogram. And compared to the sale of electric vehicles, the mustard color portion, come see the number of vehicles in 2010 to 17. The y-axis is lithium batteries sales. It has gone to 120 compared to 2010 to 2017, indicating that the sales of electric vehicles is increasing day by day. But then we are all afraid of, I don't know whether you have heard this or not, lithium ion, we are afraid of a fire, that they may burst. You must have also read in the newspapers somewhere that it gives fire, the lithium ion batteries are giving fire. So let us see what are the disadvantages and what is it leading to these lithium fires. Lithium is, a very reactive material, just like sodium. That is the first reason. So it causes a tendency to overheat, and it can be damaged at high voltage. You must have heard of the Boeing 787 aircraft that was called back because some battery fires were reported. And because of this, a number of shipping companies, they refused to perform bulk shipments of batteries by plane. They stopped taking these batteries by plane because the plane itself is having one battery, and we are loading for transportation of batteries into the plane. So when you are keeping all these batteries nearby, also it created a fire. Of course, another limiting factor nowadays we are not bothered is 40% higher than a nickel cadmium battery. The cost of a lithium is 40% more than other batteries. This is a place where the blue one is showing you the Japan Airlines Boeing 787 lithium cobalt oxide battery that caught fire in 2013. And of course, the Samsung was forced to recall its Galaxy Note 7 handset because of a lithium ion fire. So let us see why we are afraid of these lithium ion batteries, and in the first place, why do they explode? Whether we should be careful, whether we should use them often or we should stop using them. Okay, so why do these lithium batteries explode? The first is, of course, the manufacturing defect. Some impurities, they go into lithium during the manufacturing process, and I will tell you about a separator along with anode, cathode and an electrolyte. We know any electrochemical cell consists of an anode, a cathode and an electrolyte. There is one more thing that is required, that is called a separator in between the cathode and anode, because it stops, like I said, short circuiting of the lithium was taking place. If you have a separator in between the cathode and the anode, you can stop this kind of a short circuit. That is why a separator is also used in a lithium ion battery. Okay, so whenever there is a thinning of the separator, again there is a problem of short circuiting and design flaws. There may be some mistake during the design. And the other one, that is the abnormal or improper use. This is very useful for us. If you keep a battery very close to a heat source or a nearby fire, that also will cause the battery to explode. And so you should not use the packing material, and the battery pack that is used should be from an authorized company. And coming to charger issues, poorly insulated chargers can also damage the battery. If the charger shorts or generates heat near the battery, it should do good enough damage to the cause failure. Like I have here, I'll tell you the different kinds of possibilities of damage for a lithium ion. One is mechanical. That means you throw it somewhere or something falls on it. That may also cause a damage. The second is thermal. Thermal means you should not keep it near a hot object. Second, electrical abuse. Electrical abuse is related to the separator. The separator may not be very good, or some other short circuit may take place. When during any of these is taking place, I said heat or gases that are produced in this during this oxidation or reduction. There might be some oxygen that is coming out, or the electrolyte may have some solvents. The electrolyte may have some solvents which during the reaction may release some gases like CO2 or O2. They may all aid combustion, and whenever the gases are produced, the battery bulges and it explodes. So the three reasons again I have said. One is short circuiting, overcharging. So we normally, whenever we don't have a charger, we use somebody else's charger. That is a wrong thing to do, because that your other person's charger for your phone, your charger may be, or your phone may get overcharged, or some electrical problem may take place. So we should never use somebody else's charger for ours. And here also, we should not see like the earlier batteries that it is completely charged. 100% charge is not required, because overcharging is not good for lithium. You can stop at 80% charge. These and electrolyte breakdown, I was telling you, dimethyl carbonate that is used can release some gases again, which will result in the bursting of the battery. So how do we minimize it? Some safety tips are to use it at high temperatures, and you should never keep all these batteries at one place, and never overcharge your batteries. That's what I said. Use a charger that is made only for lithium-ion batteries. And okay, this is about the lithium-ion batteries that are existing till now, or the starting ones when the discovery was made. So now, because I have shown you some advantages and some disadvantages also for lithium-ion. So how do we take care of the disadvantages, and how do we produce better and better lithium-ion batteries? That is the research that has to be taken care of today. And the key parameters that we should take care of are energy density, that is the power density, the cycle time, the charging rate, the safety, the cost, and the temperature stability. All these are the factors that should be taken care of when you are making a lithium-ion battery. And if you see, this is called the roadmap for until 2025. Roadmap means what? So what is going to, how is the technology developing until 2025? If you see the technology wise, until now, until 2010, we could make batteries of less than 4 volts. But now in 2015, you could make for 4.5. 20, you can make, we are able to make 5 volts battery. And 2025, we should make more than 5 volts. That is the aim or objective. And coming to the cathode, we were using lithium iron phosphate, and better cathodes can be used. Anodes also are mostly modified graphites earlier. Now silicon alloys are also trying. Electrolyte also, I told you, is mostly a liquid electrolyte or an organic solvent. Now the research is on using a solid electrolyte and a good separator also. So we should make batteries of 5 volts with gel polymer electrolyte or a solid electrolyte. What happens when the solid electrolyte is there, or the separator is made up of solid, some polymer membrane? So when there is a short circuit or some problem is there, automatically the solid melts down, and there is no contact between the anode and cathode, so no fire will take place. So this is from 2007, the advances or what we should do until 2025. So you see this graph where I have capacity on the x-axis and potential on the y-axis, and the blue region is where we should work, and the yellow, the lighter side is showing the batteries, the cathodes and the anodes that are existing till today, and the blue portion shows you what are the future electrodes that we should take. So the future electrodes, lithium should be combined with sulfur or oxygen, and then it will be a good cathode. What kind of modification should take place for the electrolyte? And these are some type of solid electrolytes that can be used. And we can conclude by saying that batteries based on lithium-ion chemistry, though it has some disadvantages, they are going to remain the technology of choice for many decades to come. You cannot eliminate the lithium-ion batteries now. It has come so much into the market that no, lithium-ion batteries cannot be eliminated. Only thing is you should make them better and better. Only in the long run, other lithium and non-lithium based chemistries are expected to gain ground. And so the research is on now to produce better and better cathodes, better and better anodes, good separators and good electrolytes. So this is, that's why I say this is the big revolution I was telling you. That's why I'm telling you it is a disruptive technology. Okay, these lithium-ion batteries. So, when you do, where chemistry is coming here. So here you can see we are preparing some nanostructured material, and then we do a characterization, and then we test the electrical properties of that particular material. Anybody in a chemistry lab, first what we do some synthesis. After that product is made, we should test it, whether it is same, what we are expecting we have got or not, using some spectroscopic techniques. And because everybody is talking about nanomaterials now, we use a SEM, TEM and all to characterize a particular compound. And then we should test for the electrical property, conductivity should be more, capacitance, all this has to be tested. So this is what we also have been doing in the lab, where in my students, one of my students has made graphene oxide and reduced graphene oxide and some nitrogen doped graphene oxide we are doing. It is as simple, the apparatus or the setup is as simple as this, where we use some beakers and heat it, use some oxidizing agent, as simple as this. And then I wanted to show you, so we were working on this graphene oxide. And graphene oxide nowadays is considered as a good electrode, good cathode sometimes and even an anode. So we have done this. Our idea was to make, you can see the blue part and the battery one and the super capacitor power. Now hybrid electrochemical storage devices are in today. So our idea is to finally make a hybrid supercapacitor where you have a supercapacitor and a battery together. So this is what we were doing in the lab. So what I wanted to tell you was the chemistry that what we are doing in the lab has gone up to which place? It has gone up to electrical vehicles. So that's what I conclude by saying chemistry is everywhere, sir. Right from the toothpaste that we use to the mosquito coil that we use for sleeping. So these are other proof that without chemistry, nothing here and nothing in the world. Okay? With this I will stop.
Thank you, madam, for your wonderful presentation. The advantages of this disruptive technology on the chemistry. But as on today, we come across with various technologies, the applications of chemistry like biotechnology, nanotechnology, about the medical diagnosis technology as on today. But this is the new widening scope of technology that elevates for the betterment of the society, as if ours is a developing nations. India is one of the fast developing nations where there should be a lot of research explosion. So this is the new thrust area where Madam Gar has given a lot of embedment about the automobile. So really it's a great honor, Madam. Your way of presentations may inspire the many research scholars in our GCRJY. It elevates a lot. So might be this source of inspiration may brings a lot of achievements and laurels to many young scientists in our college. So at the outset, I request any students who are having doubts regarding the session or these deliberations made by our eminent research, our professor, Dr. P. Shamala Madam Garu, a open discussion is left over. Any doubts or clarifications from the student community or from the research scholars about the base of the basic differentiation between a sustainable technology and a disruptive technology? It's open for discussion, please. Right.
I'm actually from microbiology department and hair chemistry. And you talked about the lithium-ion batteries. Actually, lithium polymer were also made for the smartphones కదా. స్మార్ట్ఫోన్స్కి లిథియం పాలిమర్ కూడా చేస్తున్నారు కదా. సో ఇప్పుడు లిథియం అయాన్లో యాక్చువల్గా దిస్ ఎక్స్ప్లోషన్స్ అని మనకి శాంసంగ్ గెలాక్సీ నోట్ 7లో యాక్చువల్గా ఎక్స్ప్లోషన్స్ చాలా వచ్చినాయని శాంసంగ్ వాళ్ళు చేసిన చేంజ్లో పాలిమర్ యాడ్ చేశారు మ్యామ్. పాలిమర్ యాడ్ చేయడం వల్ల ఎఫిషియన్సీ తగ్గిపోయింది మ్యామ్. యాక్చువల్ అంటే బ్యాటరీ యొక్క ఎఫిషియన్సీ అయాన్ యూజ్ చేసినప్పుడు ఉన్నంత ఎఫిషియన్సీ లేదు మ్యామ్. తర్వాత ఈవెన్ ఇప్పుడు రీసెంట్గా వచ్చిన రీసెర్చ్ ప్రకారంగా ఓన్లీ అంటే పర్టికులర్గా మాట్లాడుకుంటే శాంసంగ్ ఒక్క బ్రాండ్లోనే బ్యాటరీ ఒక 5 to 6 years వచ్చేటప్పటికి ఇట్ వాస్ స్వెల్లింగ్ మ్యామ్. ఇట్ వాస్ రీసెంట్గానే స్టడీడ్ మ్యామ్ అబౌట్ ఎవ్రీ శాంసంగ్ ఫోన్ లిటరల్లీ లైక్ చాలామంది టెక్ కంపెనీస్ వాళ్ళు చేస్తారు కదా, లైక్ స్టోర్ చేస్తారు కదా, స్టోర్ చేసిన ప్రతి శాంసంగ్ ఫోన్ కూడా స్వెల్ అయింది మ్యామ్. ప్రతిదీ లిటరల్లీ నాట్ ఈవెన్ ఒక మోడల్ కూడా వదలలేదు మ్యామ్, అన్ని మోడల్స్ స్వెల్ అయిపోయినాయి మ్యామ్. సో అలా స్వెల్ అవుతున్నా అంటే లైక్ పాలిమర్ యూజ్ చేస్తున్నాం అనేసి. సో పాలిమర్ యూజ్ చేయడం వల్ల అక్కడ జరుగుతున్నది ఏమన్నా ఎక్స్ప్లెయిన్ చేస్తారు.
First thing that I should tell you is, you are asking me about whether the polymer is giving rise to that swelling. See, I told you cathode is there, anode is there, electrolyte is there, separator is there. 4 parts are there. So initially the one that was invented or discovered was lithium, metallic lithium. Now they are using, because metallic lithium there are a number of problems, they are using lithium ion. So polymer, I don't know whether you are talking about polymer as electrolyte or the separator, which part it is. But polymer, solid polymers nowadays, like you said, all the phones are giving a problem another. It's not. It is 1 in some million or something. That's all. So we need not be afraid of that fire. Until the moment we touch a phone, whether it will explode or not. It is not so dangerous nowadays. With so many modifications have been made, and it's not as dangerous as you are saying. The polymer could have been the electrolyte or it would have been the separator, but the lifetime is 2 to 3 years only, not 5 years. Maybe they have over storage can take place. Maybe they have kept the temperature was high surrounding. So many reasons for it to swell. Swelling means what? Some gas is being coming out. The gas is coming out because of some chemical reaction. The gases are sometimes, if it's oxygen or something, it is combustible. It will lead to swelling and then it will fire. But like he is telling, all sets are not getting fired and all. It is happening one in some very few.
ఎలక్ట్రోలైట్ కింద యూజ్ చేయొచ్చు కదా. ఎలక్ట్రోలైట్ కింద పాలిమర్ యూజ్ చేస్తే వచ్చే అడ్వాంటేజ్ అంటే అయాన్ కాకుండా
లిథియం అయాన్ ఉంటుంది. ఇంటర్ క్యాలేషన్ అన్నాం కదా, ఆ ఇంటర్ క్యాలేషన్కి వాడుంటారు. మీరు చెప్పండి, ఇంటర్ క్యాలేషన్ ఏంటంటే లిథియం బయట ఉంటే కదా ఈ ప్రాబ్లం అంతా వస్తుంది. సో లిథియంని మనం ఒక దానిలో పట్టేసి ఉంచితే, లైక్ గ్రాఫైట్, ఇంటర్ క్యాలేషన్ అంటున్నాం కదా, అప్పుడు ఈ ప్రాబ్లం రాదు. అలాంటి వాటికి చాలా మెటీరియల్ యూజ్ చేస్తున్నారు. ఎందుకు తినలేరు? సి వీఆర్ ఆల్వేస్ లుకింగ్ ఫర్ లైట్ వెయిట్. ఇప్పుడు లైట్ వెయిట్ లేకపోతే దిస్ ఫోన్ వుడ్ హ్యావ్ బీన్ 1 kg, no? I won't hold it. So we are always trying to go for lightweight materials. So thinning of separators and all that is going on. So ultimately we are only interested, why lithium? Why not any other metal? It is light compared to, I can also use a sodium ion, no? I can also use any other, but why we are going for lithium? It should also be light in weight. So otherwise, that's what I said, your battery, this would have been very heavy. So they are trying for thinning of membranes, separators, electrolytes, so much of this. Solid electrolyte is now the main thing.
Thank you, madam. Any doubts or queries from the participants or from the delegates? So with this, we conclude this session. So thank you, madam, on behalf of the Government College Rajahmundry in general, and in particular from the Department of Chemistry, coming long way from Andhra University to try to deliver and present a keynote address or keynote presentation on disruptive technologies on chemistry. Thank you, madam. So on behalf of the organizing committee of GCRJY from the Department of Chemistry, so it's our honor and to show our gratitude to our beloved resource person, the professor and Dr. P. Shamala Madam Garu. So please accept our cordial felicitation, madam. Now I invite our beloved principal in charge, Sri P. Sri Saila Sastri Garu, in the organizing committee, all are requested to come out to the dais.
Sir, we are not used, I am not used to these kind of things. This is embarrassing. This is embarrassing. All of you coming and at the same time very touching also.
Give a big applause. Thank you, madam. Thank you for accepting our felicitation.
It was such an enthralling lecture. Really, even to a layman, it was made very clear through the diagrams, and the way she started explaining, I cannot forget. Though I don't belong to chemistry, you have performed the chemistry. You are an alchemist. My humble request, I invite this gentleman who has asked a very pertinent question to come onto the stage and have this bouquet from Madam's hands. Please come. I want you to present Thank you. Thank you so much.
Thank you, madam. Once again, give a big applause. Now we try to start with the technical sessions. Now I invite the chairperson for this today's technical section, Dr. B. Madhav Garu, to come onto the stage and occupy his seat. So I request you to, I call upon two students. Please come onto the stage. Sai. Putri ముగ్గురు రమ్మన్న మనిషి పిల్లల్ని పీజీ స్టూడెంట్ కొద్దిగా చైర్స్ కొద్దిగా బాగా నేను పిలిచి రాజేశ్వరం నా సార్ దూరంగా పెట్టి
దూరంగా పెట్టండి అంటే కాలు ఇస్తారు కదా దూరంగా అలా తెలిపండి. A very good afternoon. Now it's time 12 p.m. So a very good afternoon all the participants, students. I am B. Madhav, lecturer in chemistry working in this college. Before getting into now we are in technical session 1 of National Conference Reach 2022. Before going into this session, I would like to ask a question to you. As we all have seen, a pandemic has happened. How many deaths have happened in world and in India? I want an answer from you. Please don't use your mobile phones. Please answer me. How many deaths have happened? How many people have lost their lives due to the dreadful coronavirus? This is my question. So many numbers I want. చెప్పండి, తెలీదా? మీరందరూ కూడా ఈ పాండమిక్ చూశారు కదా. No, in India it is 5.3 lakhs people have died due to this COVID-19, and worldwide it is 6.61 million people. 1 million is equal to 10 lakhs. 6.61 million people have died. Amid this crisis, India has emerged as a reliable friend to many of the nations, because India has supplied so many vaccines. We have supplied 24 crore doses of corona vaccine to 101 countries across the globe. It is a great achievement. We have taken up the challenge and promptly prepared the vaccine and saved many lives. In India itself, 219 crores of vaccines doses were administered. This is really a great achievement. India has emerged as a country anyone can rely upon. This is new India with great aspirations. You also should be part of this new India. What I want to make a point is the sharing in a family. We share everything. Likewise, we have shared the corona vaccine to the world. We believe in the concept of Vasudhaiva Kutumbakam, Sarve Jana Sukhino Bhavantu. These are our cultural and civilizational ethos. So we have saved millions of lives. Without the vaccine, many lives would have been lost. This is, you take this baton forward. Okay, you are the future of the nation, and everything lies in your hands. And coming to the conference, Department of Chemistry has taken efforts to bring awareness of recent technologies and equip you with the advanced knowledge. And so this conference is being organized. Now we have eminent scholars and scientists with us. They will share their expertise and knowledge. So please pay your full attention and make best of this opportunity. Now I request Srimati Rajeshwari Garu to introduce our speaker, Dr. Rambabu Dandela Garu from IOC Bhubaneswar. Please, Madam, please come on to the dais and introduce our speaker to the audience.
Thank you, sir. Respected distinguished dignitaries on the dais, faculty members, my dear students, good morning to one and all. It's my privilege to introduce Dr. Rambabu Dandela Garu, Assistant Professor, Department of Industrial and Engineering Chemistry, Institute of Chemical Technology, Master's from Dr. Chemical biology, chemical proteomics, he has published 100 research articles, granted 6 patents, and currently 7 PhD students are working under his supervision. His publications are widely cited in high impact factor journals like Nature, Angiochem, JACS, etc. Sir is an associate fellow of the Telangana and Andhra Pradesh Academy of Sciences. In his respective awards, including the EDC program Outstanding Postdoctoral Research Program by the Government of Gujarat at Bangalore University of the Median from 2013 to 2016, and the Amazon Fellowship by DST Government of India from 2017 to 2022. He is a regular reviewer of several leading and impact factor journals and national international funding agencies. So we are very grateful to Dr. Rambabu Dandela Garu for accepting our invitation and making his presence. Now I invite you, sir, and request you, sir, and let them participate in the visual presentation. Thank you, sir.
to enter into chemistry. I want to share with you something. When I entered into the college, I studied in Government College of Degree College of Khammam. Okay, same like this college only. But in our cases, morning arts college, afternoon science college. My mathematics class will start 12:10. So from my village, I traveled 12 kilometers and I enter into my class 12:10. 12:10 to 1 o'clock mathematics class. Then second class is chemistry class. I don't like chemistry. Okay. So 12 o'clock when I enter into the college, and after 1 o'clock I always open the door and going out for the that time crazy movies, Pavan Kalyan, whatever, Chiranjeevi, Mahesh Babu, those kind of movies. So 2004, 2002 I finished my degree. 2001, 2000, that time one movie called Toli Prema. Okay. I always go out. I am going to that particular movie. I watched almost 120 days continuously that movie, and suddenly one day one chemistry teacher, new teacher, entered into our college. I enter into the second year. Suddenly I am going same way. He enter into there. Okay, he asked me, where are you going? Sir, I am going to that library. I want to get some books or something. Then, okay, go and come back. I don't know he was my chemistry teacher. I went moving. Next day again same thing. He catch me. Where you are going? I am going for water, sir. No. This time you need to come to my department. I saw your attendance. Every day you are coming to the college. First class you are attended. Going second class somewhere. What you are doing basically? So I am watching movies and enjoying my life. What do you want in your life? Why you want to go every day movie? You don't like chemistry or what? No, I don't like chemistry. The teacher motivated, the way he motivated to me, that department, almost 15 faculties, chemistry faculties sitting in the department. I entered into his office. I asked him first, who are you asking me this question? This is my life. Then he told me, I am your chemistry teacher. I supposed to ask this question. See, the teacher asked me that question, then what you want to do? Then what is your background, what you are doing? He asked me so many questions. From my village, my father was farmer, 2 acres land is there. Morning to eve, until 12 o'clock I went to agriculture land. I am attending the classes. Afternoon I am enjoying my life, whatever I want. So then he asked me, so this is a degree, right? What after degree, what do you want to do? Then as usual answer, I want to do MSc Physics. Why you want to do physics? My roommate was every day studying physics. I failed my first year physics. I want to see end of the physics. Then he told me, you are already failed. What you are going to do with physics? Try to learn some chemistry. And then I asked one question to him. If I pass degree, there is a possibility to get the job immediately. Why not? You need to do again MSc Chemistry. Then there is a possibility. Okay, sir, I will start reading chemistry. Then he told me one put condition. You are a second year chemistry student. He asked me 10 questions. What is alkene? What is alkane? What is alkane? I don't have answer. Alkene, what is that? I don't know. So suddenly I changed my mindset. Sir, the way impressed with me. He always coming to me and asking questions in the classroom also. But he put a condition, you need to attend 3 continuous classes. BSc Chemistry first year, BSc Chemistry second year, BSc third year. Again, you need to attend zoology. I am going to take a chemistry class to them also. You need to attend the class. In front of girls, if somebody asks question, it's very difficult, right? Answer. If you are not giving answer, girls are looking like this. And then suddenly, somewhere I felt shy. Okay, I started reading. I am not a wonderful chemistry person, but that time degree college given me something in my life. So I finished my degree that time. I was an average student. Then I asked him, I want to do MSc Chemistry. So you passed chemistry, but MSc there is an entrance, you need to qualify for that entrance. So my teacher was very nice. Again he given me opportunity. He sent his own student who is running a chemistry coaching center in Hyderabad. There is a Chem, Erudite, that kind of coaching center. I went there. Then I didn't I got my MSc Chemistry seat in Kakatiya University. After 2 years, I finished my whatever MSc Chemistry. I came back to my teacher. I asked him, after finishing MSc, you are going to give me job, right? So again, he told me, one of my friend is coming to arrange a conference in degree college. You can come to that conference. One of his friend is working in Matrix Laboratories. He given a nice presentation as an industrialist. We will develop these drugs and that drugs and everything. That time he introduced to me that industrial person. So okay, you finished MSc Chemistry. Why not? You can come and give an interview to our company. I went for interview. I don't have any knowledge what we did theoretical. There is a NMR, there is a proton, you can understand, there is a carbon, you can take it. But he asked me what is the methanol spectra. I wrote like this is the spectra. No, this is the methanol spectra, this is x-axis, y-axis is like this. Whatever bookish knowledge we have, we presented, but that is not enough for them basically. Then I realized they didn't give me job. I came back to my sir. Sir, I went for the job. They didn't select me. He immediately called him. Why you didn't give a job to him? No, he don't know anything. Basically, ethanol spectrum. My sir told me, if you know everything, why I will send you? He will go somewhere. Right? So again, he told me there is after 2 months there is a interviews. You need to come to the interview again. I prepared like name reaction and everything, whatever you know. 2 months I prepared everything. Probably I convinced that company I know something chemistry knowledge. Because of my teacher only, I entered into my life for after my MSc. I started my little bit research, whatever I know basically. When I enter into that industry, they are doing this kind of molecules. This is a matrix laboratory industry. There is a lisinopril acid. There is a anti-hypertensive drug. There is a carbonyl phosphate. In this is not happening in pharmaceutical industry, there is a lot of a process of the drug molecules. Okay. So small step 2, then stage 1, we need to reduce the number of steps, we need to reduce the cost effective, we need to come up with new procedures. So I started enjoying everything in my life. Whatever my MSc prospects, other prospects, they got some jobs from other industries. So that time we discussed with each other what are MSc prospects. One of my close friends, I know, her name is Geeta. She is working on Dr. Reddy's. I am working on Matrix. Okay. Dr. Reddy's is highway company, right? So she is getting good salary compared to me. She is doing really good. Okay. My friend told me one day Dr. Reddy's is going to start for an institute in Hyderabad Central University. There is an institute name called Institute of Life Sciences. Dr. Anjali, his passion is he wants to do some academic industry collaboration research. So that time I realized I finished 4 years in Matrix labs. Then I entered into I want to do PhD. Everybody, if you enter into the industry jobs, again, if you do PhD, your career is good something. Then I went back my teacher. I am Matrix, I am satisfying my job. I am getting 40,000 rupees. He told me, don't care about money. You can resign and go and join this company to do PhD. My father and mother asked me to go for marriage. Okay. You are getting 40,000, you will get a good job at this moment. If you resign, if you go there, there is a 6,000 day of fellowship, right? So it's very tough to make decisions. My teacher always supported me, go for PhD. Then I resigned blindly the job, 40,000 rupees. I entered into this Dr. Reddy's. There I am getting 6,000 day of fellowship. We need to do industry projects as well as our PhD research work. So at that time, there is Dr. Reddy's metformin is the hard molecule. So we develop novel process for metformin and some polymorphism of nutraceutical molecules and metformin and another urate acid is anti-obesity. These kind of molecules we develop. We are doing nice and everything is going good. Then when I enter into my PhD, as an industry I know how to do synthesized molecule. If you take a simple molecule like this, there is a multi-component reactions, leach acid-based reaction or metal-catalyzed reactions. You need to synthesize your molecule, and the ideal institute is first floor is completely organic chemistry, ground floor is biology.
whatever we synthesize the molecules, they will do the analysis for us. But during this PhD, if you want to enter into a PhD, I was conducted an exam for free entrance exam. There are 600 applicants, only 10 students selected. 10 out of them, 3 from this college. 3 of them from this college. Okay. One of my friends, here some faculty subjects, some of them I know. Some of my friends who are doing other institutes also. One person is Jelly Venkata Prasad, event for PhD Japan. Another person Narendra Reddy, event for USA. Most of the friends, if they came from this college, they don't know the industry experience. I know the industry experience, I don't have basis properly. We started doing our business research, we sit together, this we can do like this can do like this. Most of 3 or 4 of us will publish lot of papers in this particular synthetic medicinal chemistry area. So after PhD, everybody is going to go that night. So again, we planned for postdoc that time. I went for Bengal University, Israel. Again, here also some problem. There are rockets from Gaza that time. My father told me, you are the only one son, you are supposed to marry, why you are doing these stupid things. His expectation is different. Okay. So he went, I told him 1 year I will come back and do everything in India only. But it took me 4 years during my postdoctoral education also. Why it took 4 years? I am a chemist, I can synthesize molecules, but I don't know biology. But when I entered into my postdoc lab, they gave me biology project. You need to grow agar cells, bacteria. I don't know anything, I know only enough reactions, I can do something. My supervisor was very angry. Next day I went to his office, Microsoft is very difficult, I told him, why are you coming so stupid? Don't come, only Michael. He was very aggressive. Okay. Then I understand what he said I need to do. Then I started doing biology 1 month. What I am doing I don't know. Okay. After that I realized this is not right place for me, I need to move from this place. See, you need to talk with some other people, then only you will get some ideas. If you don't talk with other people, it's very difficult in your life. Whatever the 1 month I struggled, every day I am going to lab, what I am doing I don't know during my postdoc, I am coming back evening, just simply sitting back. Then I realized with another chemistry who was doing postdoc at that time from IIT Hyderabad, he told me, whatever you said you can do, but you sometimes, whatever you want to do, you can do in your way. Then I realized, morning I did biology, night I started doing synthetic organic chemistry, whatever I know. And night time there was no anyone there, whatever my favorite Telugu songs I can put there, and I am enjoying my music, I synthesize some molecules like this. What are the molecules that time they are doing? Like a human beings, we are talking to each other, bacteria also talk to each other, it will produce some chemicals. What kind of chemicals it will form? Like this homocellular atoms, there is a covalent molecule, there is a peptide molecules. Then I started realizing that whenever your health is getting disease, how is getting disease? There is a epithelial cells, there is skin cells, there is a balance between your skin cells and your health related issues. Your health will be automatically disturbed to the bacteria. Because bacteria is always problem for you, whatever is happening. So I started understanding to conduct some experiment in biology. And one day my supervisor organized a group meeting. One PhD student is presenting his work that time. He was coming from last 1 year to synthesize this molecule basically. This is a cycle after that time. There is a chromophore will be there. It will be synthesized from 4 steps. Then I told him I synthesize this molecule better than this chromophore. What? Did you do this? I gave a biology project.
Why you synthesize that molecule? I read the literature, this molecule has some importance, pyridine, chelator. As a its name is pyridine, that is the iron chelator. So he asked me how you synthesize. There is a peptide synthesis will be there. You need to take a resin, you need to put your resin. There is amino acids, right? Alanine, valine, like that. There is a sequence. Each amino acid you need to protect, deprotect. You need to do HPLC at the end. You will get your peptide, cyclopeptide. So my research supervisor realized what you are doing last 1-2 months, this kind of things. He called me his office. He asked me how many instruments you used. He checked all the data. I took NMRs, HPLC. You supposed to tell me, right? Yes, I convinced him I am passionate in chemistry, I can do biology also. Then he told me, this fellow is struggling for 2 years to teach them how to synthesize this molecule. Then I got an opportunity to work with him. That fellow is strong in biology. Okay. He taught me, that is PhD student, he taught me how to grow the bacteria, how to take a colonies, how to check the luminescence, how to use particular inhibitor. If bacterial cells -78, they stored in some ground floor, some department. I don't know where was it also. He guided me very nicely. You need to take right cells. There are Pseudomonas aeruginosa, E. coli, a lot of bacteria cells will be there, right? You can take right bacteria, you can do right experiments. It's okay, everything fine. I am doing basic biology. Okay, I am publishing something. One day, madam discussed click chemistry, right? What is that click chemistry? Anybody know? There is an azide, there is an alkyne. You will do click chemistry, you will get a triazole or tetrazole kind of this kind of molecules. That time, who was received Nobel Prize recently, Carmen Bedrosian, she was visiting our campus. That time she discussed there is a natural product. You can synthesize the natural products inspired probe. That probe containing alkyne moiety. This is alkyne means C-triple-bond-C. You can take that moiety, you can incubate your bacterial cells, whatever you are growing, and how it's grown, it will interact your target molecule. Then you can do something click chemistry kind of thing. There is a azide, there is an alkyne, there is a natural products inspired probe. You will get your click chemistry. Then what kind of proteins you are identified for target identification, it will be used by MS spectrometers or SDS gel spectrometer. So when I saw the presentation, until here I am clear, at least what I am doing. And this is the chemistry part only I can do. At the end, what is the SDS gel, what is the mass spectroscopy? Mass spectroscopy I know. What will give mass spectroscopy? Your molecule M+1 peak or M+1 peak. But there is a mass spectroscopy related to MS analysis also. You need to deeply look into that particular spectra. You need to analyze your peptides. Peptide sequence, it will give protein. For proteins again, protein database bank will be there. What kind of proteins you are identified? Either good protein or bad protein, or it's related to your disease. This is the simple flowchart she presented that time. Then I started working whatever this bacterial signaling molecule. There is a molecule will be there PQS. There is a challenge, you need to put diazoline group. When you pass the light, UV light, it attacks to your bacterial cells, covalent inhibition. You need to put your alkyne, then do click chemistry. And there is a Pseudomonas signaling molecule, we identify a lot of proteins. Why actually this molecule acting as a bacterial signaling molecule. There is another one is called, by using this chemical proteomics PCR probe, phosphorus-amide NMR. Lot of molecules we synthesize, we did some chemical proteomics. It took 4 years. I supposed to come back after 1 year, but it took me 4 years. So then I moved to India. What I need to do, I don't know, right? That time after 4 years, if you want to go by an industry, Israel will get good salaries, right? And the quota will get good salaries. Again, if you go back to India, you want to the quota, they will give less salary. Okay, getting that was very difficult in India that time. So I thought that I can apply some fellowships. I can go, and my passion is academic teaching and research. So I applied Ramanujan fellowship. I selected in NCL Pune that time. I joined in NCL Pune 2017. Basically what I did there, as I come back to India, I want to do some kind of research same related to chemical proteomics, but if there is a, how you are getting protein. Usually natural amino acids, transcription, translation, you will get your protein. Instead of natural amino acids, you put your unnatural amino acids in protein, you will follow same procedure. Whatever you put unnatural amino acids somewhere in your protein, and you want to do biophysical studies of the protein. So this kind of research I proposed. When I entered into the NCL Pune, there is an organic chemistry department. You can synthesize your molecule. Again, you need to go to biology lab. You need to do some kind of this kind of work. So we started that kind of research. So based on that, we synthesize this kind of amino acids, we put into the protein, we analyze that molecule, what kind of target identification, what are the proteins basically. So during that time, if your age is cross 37, there is no opportunity for in CSR institutes. So my age is 38. So getting job in India is very difficult. That particular point now also 2007, most of my friends faculty here also they realize that once you get PhD and postdoc, once you come back India to get job in academic institutions, it's very difficult. You people are lucky. Most of my friends are here basically to take care of you. So I am happy for that. But when I applied the position ICT IOC Bhubaneswar, there is a campus called Institute of Chemical Technology. Maybe everybody know in Mumbai there is a campus. They started off campus in Bhubaneswar. Their aim is you need to do research, not only basic research, you need to apply for industry related. Our department also not chemistry department, industrial and engineering chemistry department. So in that point, what kind of industry related work you can do? So we started newly, we don't have any facilities basically. Indian Oil Corporation given 500 crores funding for us. We ordered some instrumentations, all instruments, around 70 crores. It took time. That time what I did, some methodology kind of research methodologies we do. Basically endocyclic compounds, everybody know endocyclic compounds have drugs. And then there is a conventional synthesis. There is a sonicator, sonication will be there, sonicator, box sonicator. It cost you 15,000 rupees. We purchased that 15,000 box sonicator. We did some normal reaction and sonications. And we synthesized some new molecules. We tested their biological activity. For example, if you see this molecule, there is a vinyl azide is there. So we took simple secondary amines. Then there is a alpha keto amides we synthesized from this vinyl azides. There is a C bond O formation, C bond N formation at room temperature. You will get this kind of thing. So, there are a lot of molecules, diketoamides in the literature, drug molecules, and a lot of procedures already reported in this particular synthesizing molecules from acid chlorides or alkene or vinyl something. Whatever our new methodology is related to vinyl azide, simple iodine you can take, you will get your product. And one of the compound we observed single crystal exorography and electron withdrawing group, electron donating group, everything we obtain good yields. And I am a pharma background, right? So I want to apply my methodology. I do some anti-cancer drugs. This is the Session-1 is the anti-cancer drug used in small cell lung cancer. We took the secondary agent. We attach this vinyl alpha ketoamide Session-1 derivatives we synthesize. And if you are coming industry background, you want to show your methodology in gram scale also. We synthesize same methodology in 1.3 gram scale. We publish this publication in OBC. And another methodology related to multi-component kind of thing, not really multi-component, iodine is related to this particular thing. And there is a alkene and benzylamines reacted, you will get your benzylamine under this substituted imidazole. This is the imidazole moiety, you will get this kind of products. And we showed some application for tetrazole click chemistry. This is the benzimidazole imidazole related drug molecule, lorsatran, eposatran, epactazole, olmesatran. And these are the reported methods. I am not going too much details in the chemistry, but we developed novel methodology related to iodine, and DMSO as the not solvent, we took 4 equivalents. Here also whatever product we showed single crystal exorography and electron donating group or electron withdrawing group, what will happen actually. We dip this whatever benzimidazole moiety, we dip debenzylation of this phenyl group, you will get your NH. Again we did propagylation, whatever you will get your aryl azides, you will get do chemistry, you will get your this kind of products. So we showed again this molecule in gram scale also. These are the advantage of these protocols. I am not going too much details in this. And another paper we collaborated with Tirupati Baralasar, here I said Berampur. We did this kind of work. We took tyrosine moiety, N-benzylation or particular aniline reactions. We will do this kind of in ether linkage also we showed.
and there are drug molecules, whatever related to this particular moieties, and we showed them. We synthesized several molecules and we showed application as a propargyl bromide and click chemistry kind of things. Again, tyrosine derivatives, we do same protocols and written on methanol, we showed the spectrography particular this molecule also. So we are doing same this kind of ether linkage also. These are the ether linkage we will apply to this also. So another same thing related to this time we synthesize the compound. This is the sonicator. You need to take the sonicator and the MA is there, amper is there. You will get a pyramidal imidazole kind of compounds. We tested these molecules. There is a simple reaction, we can design it like this. There is a very D and E, you can see the reported literature. These are the possible temperatures for biological activity. And we synthesize this molecule from this protocol. And we did some docking studies to support our biological activity. So same as sonicator, we took another reagent molecule. You can take this sonicator molecule, which is a polyethylene glycol with green powder, we did some kind of reactions. So we are doing same thing again after sonication and we are publishing some papers related to this area. And there is a hydrobenzoate, again we are taking dextro kind of molecule. There is a DMSO CZ compound we get and we show some cytotoxic reagent related to application part of the particular molecule. And another molecule is synthetic communication we published. We did this kind of reactions. Okay, everything is going on normally. We are doing a lot of methodologies in this area relating pharma communication. During my first year, second year in my industrial chemistry assistant professor job, we did this kind of chemistry. So after I attended 2018 this conference, there is an IUCR conference, Indian Crystallography conference. This was organized by Hyderabad, Professor Dr. Vishal. He is from IIC Bangalore. He previously was in Hyderabad Chemistry. He was doing this crystalline research, and Professor Maya also he was in Hyderabad Chemistry. He is also doing this kind of crystalline research. Whenever in LCR he was the director, that time he was looking for me to establish his lab. We need to do something in LCR only. But I started when I moved as an assistant professor here. So I started thinking about literature. There is a acid-acid interaction, acid-amide interaction, or amide-amide interaction. Like this interaction we observed in the crystallography. As a crystallographer, I know only how to make synthesize molecule to crystallize the molecule. If you take your compound, you put in some solvent, you will get your crystal. You can put in single crystal explanation, you will do the RF diagram, that kind of thing. But they are working as a pharmaceutical co-creators. That they will take a drug molecule, whatever the approved co-compound will be there, they will take that molecule, they will combine by using crystal engineering principles. So in that time they show this kind of phenomena in the crystal engineering, polymorphism, neutral co-crystals, whatever solid dispersion, salt formation. Again I thought myself maybe I did the same thing in my matrix experience, whatever Dr. Reddy's experience. You will synthesize your drug molecule, at the end you will prepare a salt to improve the solubility of that particular compound. So I started understanding this literature. There is a paracetamol molecule is there. So there is a possibility to kind some polymorphism in paracetamol. There is a different monoclonic P2-1 space group. If it's abdorambic, PBCA space group will be there. So polymorphism I understand from this particular paper, but you will take a drug molecule, you will get different polymorphs in different solvents. If it's a solvent including the drug molecule, it's called as a solvate. If there is no solvent, it's a different polymorphs you can observe. In literature, there were a lot of started literature thinking there is a BCS classification, biochemical classification. According to that classification, class 1 drugs are the high solubility, high permeability. Class 2 is the low solubility, high permeability. Class 3 is the high solubility, low permeability. Class 4 is the low solubility and low permeability. When I started searching literature, most of the marketed drugs and pipeline drugs, 70% drugs are BCS class 2. That means less soluble or more permeable. If you take that particular compound, you can improve the solubility. So we choose this study, BCS class 2 drugs, whatever low solubility, or class 4 low solubility and high permeability. When I started the literature, there is a how you are improving the bioavailability or solubility of the drug by using crystal engineering principle, either co-crystallization or use polymorphs or etc. In that talk, they simple, there is a sugar will be there, right, in our home. Sugar is more crystalline and sodium chloride salt is less crystalline and it will soluble immediately. Sugar is more crystalline. So like that, there is a crystalline structure, 3D structure will be there. If you see this slide, crystalline material, you will get single crystal like this. There is a powder, crystalline powder, like sugar. There is atoms arrangement in same grain. So this is simple phenomena, you can understand very easily. And that time, there is a Braggs law. Everybody thinks this 2D sine theta is equal to n lambda, Braggs law. That time this was the famous Nobel Prize winner, right? Braggs. So I started understanding this literature, and then you can see here in this wavelength you will get your UV rays related to a particular single crystal instrument. So whatever remaining things, we learned everything in my PhD about the UV light or whatever IR spectroscopy, everything. So I started learning how interaction X-rays into the particular matter. That time when we put single crystal in our instruments, it look like this. If it's a polycrystalline, it will show like this. Suppose single crystalline, how it will diffract, we will show the figure, diffraction. This is the single crystal diffraction, you will get like this. Powder diffraction, you will get these peaks. If these peaks are more crystalline nature is there. If peaks are less, that is amorphous nature. So for example, I showed some here one drug molecule or crystal. If it's a more peaks will be there, liquid kind of things, it will be amorphous kind of thing. So I started understanding this thing. There is a simple thing like API is the pharmaceutical drugs like cancer drug or whatever it may be. There is a co-farmer, FDA approved co-farmer. Okay. Suppose why I put cartoon, there is a boy and girl, right? Boy is drug, girl is co-farmer. If they are interested, they will give share time. If they don't want interest, they will go away, right? So in that case also API has some functional group like acid, amide, something. This co-farmer has some functional group.